So yesterday we started Unit 6 and we were trying to understand the meaning of state functions. So what do you know about state functions? State functions like delta H, delta S, delta G, even this E is state function, delta E. So what's the meaning? Meaning of state function, Dhruv? Meaning is they depend on final and initial state. Final and initial state, and they are independent of path. Initial state. And they are independent of path. Path doesn't matter. Whether you do the reaction in single one way, one step, or you do the reaction in multiple steps, the total change from initial to final, that is what is the magnitude of these thermodynamic functions. So state function depends only on a state function. It depends on initial and final. Next time when I say, what do you mean by state function? Please answer it that it depends on initial and final uh, values. It does not depend on the path. Like for example, the target is to reach the school from home. This is your home and this is the school. The target is to go to the school. Okay, this is the target. Now, whether you go to the school like this, or like this, or like this, it doesn't matter. Are you in the school? Yes, I'm in the school. And work is done. Okay, we are done. He's in the school. So it means state function. Finally, school, initially is home. So we are not taking into account the path you followed to reach the school. That's the meaning of state function, right? So all these are state functions. Because they are state functions, we are going to use Hess's law on them. Hess's law. We are going to use Hess's law on them. No problem. Shrihan, we are just doing a review of what we did yesterday. So children, what is the meaning of state functions? What is the meaning of state function? Type it here. They are independent of path. They depend only on initial and final state. Like for example, this is a cup of water. There is water in it. Temperature of the water is 25 degrees Celsius. And I gave this as two such cup of water, one to Dhruv, other to Shrihan. And I said, okay, raise the temperature to 50 degrees Celsius. Both of them, they took this cup and they went. And then after some time, they were back and they said, okay, this is now 50. And I checked, oh yeah, it is 50. So final 50, initial 25, I didn't ask them how you did it. Maybe Shrihan raised the temperature by using a heater. Maybe Dhruv has raised the temperature by using a microwave, or maybe by using some gas, burning gas. So there are so many ways in which I can raise the temperature from 25 to 50. The heat supplied can be by any method. Electric heater, electricity, or gas heat from gas, or microwave. It doesn't matter at all. Path doesn't matter because the final temperature is 50. So what is delta T? State function? Delta T is a state function, change in temperature. Change in temperature. So children, is it clear? State function word? Okay. Now yesterday we were doing about this internal energy and we reached up to this equation that delta E is Q plus W. Then we discussed that W is minus P delta V. Children, this Q and W, they, they are not state functions. Q and W are not state functions. Q and W, they depend on path. They are path dependent. Path dependent. What is Q here? Please type here. What is Q? Sarayu, what is Q? Q represents? Yes, Sarayu. Q represents? Saranya? No. Q represents here? Siri? Lasya? Sanjana? What does this Q represent? See? Simple things. Okay, Lasya. Feel good, okay? Take care. Lasya is not so well today. Sanjana, yes. It is heat. Very good. See, children, when I asked a simple question, what we did yesterday, you took so much time. Heat. Q represents heat. So, Lasya, don't worry. You need not to answer questions. I know that you are good. W. What does W represents? W, children? W represents work. They are path dependent functions. They depend on path. Path means, like, for example, this is a hill. This is a hill. And I'm asking you to go on the top of the hill. Here. You are here. Go here. What Lasya did? She took a chopper and landed like this. Tuck. With the help of chopper. She did that. Sanjana, she said, okay, I'm brave. I'll go like this. And then Sarayu, she said, oh no, I will take a car and will go like this. Do you think the amount of work done by Lasya here, Lasya is here. So I'm just writing L for Lasya. This is the work done by Lasya. This is the work done by Sanjana. This is the work done by Sarayu. Are they doing the same amount of work, children? They followed different path. Are they doing same amount of work? No. But they all are here finally. They all are here from here. They all are here. So it means work is path dependent. Last year did zero work. When somebody goes up this like this, in physics, if you use an equation with cos theta and all these, this is zero work done. She did zero work and she's there. Sanjana, she used a great amount of heat. You know, when she is traveling up, she will be sweating also. Heat will be generated in her body, more heat. So the amount of heat and amount of work when these three girls are trying to reach the top of the hill is different here. So Q and W are path dependent. Please write it down. And remember, in thermodynamics, all capital functions, all capital, the one which are represented by capital letters, all capital letters function, you are going to do more later on, are state functions. If you are learning physics and then maybe later in the college also, in small letters, you know, Q and W, they are represented by, I'm not writing W like this. No, I'm writing it like this, small. All small letters, they are path dependent function. Path dependent function. We are good? Okay, now I'm taking you on the next important topic, which we have started doing yesterday, sign convention. So, what are sign conventions? So, you take your system. System is the part of the universe under observation, like a bank. System is like a bank. Anything added to the system, if you add something to the system, anything added to the system, see here, look at the arrow, added, anything. Now, what are the things we are talking about? Q and W. Q is the heat added to the system. W is the work done on the system, work done on the system, right? Is positive. Will have a positive sign. And anything removed from the system, removed, removed. Like from the bank, you are taking out money, it will become negative. And what we are removed, we are with the system. Actually, it's not bank. We are talking about the system. So what we are removing from the system, heat. You remove heat, it's negative. W. W is work done by the system now. See the difference. Work done on the system, work done by the system. When system is doing work by the system, then system is using its energy. For doing work, we need energy. If system is doing work, then that work will be taken as negative. Sign conventions are very important. We are going to do questions based on it. What is happening here? The piston is moving up, right? Check. Can I say this is expansion of gas? Expansion of gas. Can I say, see here, see the change? This piston is going up, expansion of gas. Can you tell me who is doing work? The system or surroundings in this diagram? Who is doing work? This piston is going up. So this work done is negative work. Very good, Siri. Very fast answer. Good class here. This work done is negative or positive? Yes, Sanjana. This work done is negative or positive? Expansion of gas, all of you are right, is the work done by the system. Work done by the system. So it should be negative work done. The system is using its energy, its own energy, its internal energy to do the work. Work done by the system. So please write down. Expansion of gases is always the work done by the system, right? Now let's see this container. Piston here. There's a piston here. Movable piston, moving piston, and there is a gas here. I applied pressure from outside, surroundings. Surroundings is applying a force. Piston moved down like this. Now who is doing work here in this change? Gas is the system. This part is the surroundings. So who is doing work? Surroundings. So what will happen to the energy of the surroundings? Energy of the surroundings will go down, but energy of the system will go up. So here work is done on the system. Work is done on the system. Agreed, children? So this work done is positive. But what is this? This is compression of a gas. Compression. We are compressing a gas. Compression of a gas. So it means whenever a gas is undergoing compression, then the work done is positive. So whenever a gas is undergoing compression, work done is positive. Whenever a gas is undergoing expansion, the work done is negative. I think we are clear about it. Because this equation, work done is minus P delta V. We are going to use only for gases. Because only gases, they show a significant change in the volumes when the pressures are changing. Solids and liquids, they don't show significant changes. Volume changes are very less. So this equation is for gases. Okay, otherwise we have to use this equation. Work done is force multiplied by distance. But that we are using in physics. So we are good? Sign convention. Any question here? Take your system like a bank and anything added to the bank. Anything added means like heat, work added to the bank is positive. Anything removed from the bank, the system, is negative. So questions now. Question 29, children. So all of you please type the equation of delta E. What is delta E, children? And what does this E represents? E is the total internal energy. Next time when I ask you this question, please try to answer. And this change in total internal energy is equal to, yes, Q plus W. Who is this? Dhruv, very good. Srayu, perfect. Sanjana, good. Q plus W. Yes. Answer 29. A gas absorbs. So this heat is added or removed from the system? This is heat added. So it should be plus 45 kilojoules. Does 29 kilojoules of work. The gas is the system. So it's doing work. So this work is negative. Very good. Minus 29 kilojoule. Calculate delta E. You can do it. So this delta E, what is the sign of delta E finally? Is it 16 plus? So what is happening? This plus sign indicates there is a increase in total internal energy. Yes, increase means the system internal energy is increasing. Okay, let's do question 30. This is 29, children. We are doing 30 now. Ready? When I ask simple question, what is E? What is the equation of delta E? Try to type it here. It's a way of memorizing. The system releases heat. Heat is coming out. So delta E is Q plus W. Q is minus 125 kilojoules. Yes. And while 104 kilojoule of work is done on it. So what's the sign of this work done? Work done on the gas, on the system. Yes, children? Only one student? What's the sign of work done? Yes, plus 104 kilojoule. And the answer is negative or positive? It's negative. Answer is negative, means delta E is decreasing. And I think Shrihan gave us the calculation. Is it right? kilojoules. So the total internal energy of the system will decrease. So this minus, this plus is not algebra. What is it? Minus indicates decrease in energy. Minus indicates release coming out of the system. So please understand this. Don't think that, oh, minus means um, it should be compared like an algebra number. No. Plus means increase. Increase means added, absorbed, added. Like for example, children, I have seen this question in AP exam as a free response question. Check here. Plus, okay, not plus, minus 300 kilojoules minus 100 kilojoules. Which energy is more? Which energy? And that is something wrong, Shrihan. I just explained you. Which energy is more, children? Yeah, this one. Shrihan, I just explained you. Why? Sanjana, can you tell me why you picked up this answer as more? Because she's right. She's right. This means 300 kilojoules of energy is coming out, is released. Write on this in your notes. And this means only 100 kilojoules of energy is released. Energy is released. Sarana, you're there? Today you're not answering? Saranya, you're there? Siri, you're answering. Okay, good. Please write on this. It's very important. I've seen this question. The way Shrihan initially said minus 100 because he was thinking mathematically. I was telling you, don't think mathematically. It's not this minus and plus indicates release and added. That's it. More bigger minus value means more big amount of energy is released. Okay, positive, yes, positive, there will be no confusion. Okay, moving on. Yes, children, let's do this question. You remember that I said delta E. Is delta E a state function or a path dependent function? Answer this question. Delta E is state function or path dependent? It's a state function. So you can do your changes in multiple steps. Step 1, step 2. It doesn't matter. It depends only on initial and final. So we are going to add all the steps to see what is the final, right? Okay, step 1. What is Q for step 1? Q. Give the value of Q. Q is heat, all of you know. Yes, plus 72 joules. Very good. What is W? Plus 35 kilojoules. Joules or kilojoules? Joules. Step 2. What is Q? Plus 35. See, absorbs. And what is work? Work. Saranya, why you have taken plus 72? Saranya and Who else has taken plus 72? Oh, only Saranya. Saranya is minus, right? While performing of work, the system is performing. System is doing, right? Oh, okay. Change your answer. Okay, good. Now, what is the delta E? Because it's a state function, we are doing in multiple steps, we have to see the final answer. So final answer is Q plus W. Add all these Q's. 72 plus 35. This is Q, right? W plus 35. This is plus minus 72. And that will be your answer. What's the answer? 35, 35. This is cancelled. 70. So there is an increase in internal energy, delta E. There is an increase. This much amount of extra energy is absorbed by the system. So internal energy of the system is increasing. This is one very interesting question. I will give you some time to read the question and then you start answering. I hope all of you are reading. Is there any function today, something in USA? Some students are missing. Okay, read the question, please. Sarayu, you are ready? Shrihan, Sri, you are not answering. Yeah, you are there. Good. Ready? If the internal energy, what's the sign of internal energy? Type here. Take care of the capital and small. What is the sign of internal energy you are taking? Mm-hmm. Sign. Okay, don't worry about delta. For the delta, you can write D. Dhruv, what is the sign of internal energy? No, no. Answer my question, Shrihan, first. What is the sign of internal energy? I'm not interested in final answer. Answer my question. Do you know the sign of internal energy? Symbol? Sorry, symbol, not sign. Sorry, I'm correcting myself. What's a symbol? Children? Yeah, delta E is, what's the equation? Delta E is equal to, yeah, Q plus W. Now what is delta E? Now give the value of delta E with sign. Value of delta is given with sign. Shrihan, value of delta E with sign. Yes, plus 300 joules. Work, give me the sign of work. Expansion is work done by the, remember I was showing you piston is going up, gas is expanding. Yes, it is the work done by the system. Yes, very good. Minus 75 joules. They are asking Q and the question is done. Plug in the values. 300 Q, they want to know. W minus 75. So Q is equal to, in change the side, isolate Q, 375 joules. Check the sign of Q, plus. In which direction heat is flowing? Is it flowing in the system or out of the system? In which direction heat is flowing? In the system or out of the system? Heat is gained by the system or heat is lost by the system, Sarayu? What do you think with this plus sign? The heat is flowing in the system or out of the system? Dhruv is saying gained. What about rest of you? Yes, in the system, it's a plus sign. It is added to the system. It is endothermic. It is absorbed, right? It is endothermic and it is absorbed. We are good? So that's about your delta E, internal energy of the system. Very first unit, 6.0 is done. Now the second is 6.1, which is endothermic and exothermic processes. So before we start, I think you already know exothermic, endothermic energy profiles. Energy profile is also one of the unit, but I'm not going to teach you separately because throughout this unit, we are going to do plenty of energy profiles. I think we have already started doing energy profiles. So let's do an energy profile of an endothermic process. What is here on this side? What is there? Energy. What is here? Try to answer all these simple questions. But these are the ones which are very confusing in the exam. Oh, what was here? I don't remember. I remember the profile. Progress of reaction. What is this? This one? Reactant. You know, children, it was way back, maybe around 2008 or 9, something like that. There was a student, IB chemistry student. Oh, yeah, IB chemistry. And she was doing very well, very intelligent, hardworking. And I was very happy with her work. And when the exam was over, she told me, oh, it was not, it was SAT exam. At that time, SATs were there, SAT chemistry. She told me, I got confused. I said, why? You were doing so great with the questions, everything. You know what reasons she gave me? Periodic table. She said I was confused how to use the periodic table in that exam. So I asked her, you were not practicing periodic table? Like whenever we are doing question, I generally say, keep your periodic table in front of you. See, search the element yourself. Don't Google it. She said, I did this error. And in the exam, the periodic table was uh, placed in a different manner. I used to have it in different manner. And I was confused with that. And I took time in searching the elements. See, this was the reason. And these exams, multiple choice questions, you get only 1 minute. So now this is very high time that you should start timing your questions. Oh, this is the question, I'll do it in 1 minute. Like this. Okay. And the girl was very intelligent and was doing very good. So even practicing questions and with just the periodic table is generally you place it like this. You see the periods like this. Her periodic table was like this. Or you see the groups like this. But in the periodic table, in the examination sheet, it was these were the groups. And she was confused because the paper was in the landscape kind of form. The periodic table was placed in that form. So why I'm telling you this because I want you to take care of the time also now. This is the reactant, children, and this is the product. What is this? Keep practicing all these simple things. Yes, any one of you, what is this we have done in transition state? Yes. And what is a transition state? The most unstable bond breaking, bond formation, remember that this term, bond breaking and bond formation is taking place at the transition state, the highest in energy, the most unstable form, very short lived. Short lived. It will break down immediately, right? Unstable. Write on this also. Short lived. You are learning a language also. Try to understand and see, take interest. It's an interesting language, right? Then some students are telling me about this. What is this, children? Activation energy. Activation energy. EA. And EA tells you whether the reaction will be slow or fast. It controls the kinetics, correct? Kinetics. EA controls the kinetics. A high value of activation energy, slow reaction. A low value of activation energy, fast reaction. All these things we have done. Now, if the Q heat, if it is measured at constant pressure, around you the pressure is constant, 1 atm. So when you are performing experiments in a lab, what is the pressure around you? 1 atm. What is the pressure on the reactants, products? 1 atm. So at this pressure, 1 atm, when you are measuring heat, we call it enthalpy, which is represented as H. Again, during the reaction, you cannot calculate HR. It's very difficult to know HR. It's very difficult to know HP. So what we are calculating in this energy profile, delta H. Delta H is HP minus HR. The energies of this, of course, in the energy profile, I know HR. And I said we cannot know. Here also I know this. I know this. That's only I'm calculating delta H. But this HR, HP, we are using another technique, another kind of measurement, and they are actually formation values. So we'll discuss this. H formation. So we are using these formation values for the reactants and the products. So this is another way of doing the measurement of these enthalpies. So we'll discuss this formation. It's a big topic. So are we clear about delta H here? What is the sign of delta H here, children? What is more? Look at the energy profile. What is more? Yes. What is more? Sharayu, look at the diagram. This is HR. This is HP. HP is more than HR. So what is the sign of delta H for endothermic? Plus. Heat is added. Energy can neither be created nor be destroyed. If this is 100, this is 200, and this is 500. Can you tell me what's the value of delta H? 200 minus 100 plus 100 kilojoules. Units are very important. What's the value of activation energy for the forward direction? Forward. Forward means reactant to product. What's the activation energy? 500. This value. minus this one, minus 100. These are questions, children. Plus 400 kilojoules. You're getting it? The way I calculate it for the forward direction, can you calculate activation energy for the reverse? Reverse means product to reactant. Product to reactant. This is reverse. Activation energy. Anyone? And you can see activation energy is always endothermic, positive, heat needed. Sanjana, you can hear me? Yeah, rejoin. Yes. Shrihan is saying is 200 minus 100. Why, Shrihan? I'm talking about this one. Activation energy. This one. This is EA, activation. How much is activation? 500? All these are state functions. And what is HP? 200. How much is this? Plus 300 kilojoules. Check this value and check this value. Which reaction is faster? Reactant to product or product to reactant? Which one is faster? Which reaction is faster? Compare the activation energy. Yes, Lasya, very good, Siri. Very good, Lasya. Perfect. Sarayu, you're understanding? Saranya, today you are not answering anything, dear, again. Saranya, please answer questions. Okay? Simple questions, plus minus. But they are very important. Till the time you don't try to answer here, interact with me, these things will go wrong in your head. Okay, and if you are wrong in one thing, everything will collapse. Okay, children, you're understanding? Activation energy decides the rate of the reaction. So, product to reactant is faster. Yes, Shrihan, very good. High activation means slow reaction, means low value of K, rate constant. All these, unit 5, kinetics, Arrhenius equation. Okay, another question. Which one is stable here, the reactant or product? Saranya and Sarayu, answer it. Which one is stable in this energy profile? The product or reactant? You tell me exactly what are the numbers. You know, children, Shriya is doing quizzes very regularly. Dhruv, you have not started yet. Shriyan is doing throughout the week, one or two. Every day I'm getting submissions. Shriyan, can you just send me the numbers? Okay. You can send the numbers of the quizzes which are broken. Unit 5. I think in Unit 5, maybe one or two. If you give me the numbers, I'll check them and I'll correct them. Yes, 5.8. Okay. You can send me on WhatsApp the numbers of the quizzes. If you feel any problem in the quizzes, children, you can send me quiz number on the WhatsApp. I'll correct it. It will take only a few seconds for me to correct it. Even during teaching also I can correct it. Okay. So which one is more stable? The reactant. Why? Because reactant has lower energy. Dhruv is giving us the proper reason also. So can I say in endothermic reactions, products are less stable because they are of high energy. Reactants are more stable. Activation energy for the reverse direction is low. So product to reactant, the rate of the reaction will be faster. Reactant to product, the rate of the reaction is slower. Can I say all these things? Delta H of the reaction is positive. Delta H is HP minus HR. Low activation energy means high value of K. High value of K means the rate of reaction is more. More collisions will be effective. So right now we are doing unit 9 and I'm talking so much about unit 5 also. That's how they integrate in the examination. Okay. So during revision, I will be integrating all the units. Okay. I will be discussing questions in which all the units will be integrated. So we are good with this. Now let's do exothermic reaction. So Shriyan, if you have doubt, use my forum. Children, please, if doubts are there, please don't expect that I can arrange one-to-one extra class. If doubts are there, you have to use my forum or you come back, you stay here in the class for 15 minutes. So if you stay 15 minutes for two classes, 30 minutes are more than enough to clear the doubts. Yeah, bring the doubts. You put the doubts there in the forum. I'll tell you how to memorize. We did the tricks of memorization also. I gave you the table. Keep that table in front of you. Okay? Use my forum. Use 15 minutes after the class. Children, those who are not using forums, not doing quizzes, not staying back in the class for doubts, means not doing anything. And not doing anything right now is not good. It's January. Okay? Work hard. Love the subject. Go with a slow pace. Okay, now let's see exothermic. Exothermic. In exothermic reaction, how the energy profile will go? Like this. What is here? Energy. What is here? Progress of reaction. For the reactant, you can write just R. Okay, so don't worry. I will understand. You need not to type the complete sentences. What is this? Reactant. What is this? Product. What is this? Transition state. Very good. And what is this? EA. So what is more stable here, the products or the reactants? Okay, if I give you this value as 500 and this value as 200 and this value as 900, what is delta H of the reaction? RXN means reaction. What is it? It is HP minus HR. Remember this equation. It will be there in the formula sheet. And Dhruv is answering that it will be minus 300. What does minus indicate, Dhruv? What's the meaning of this minus? That is released. It's coming out of the system, right? Minus 300 is exothermic, released. Good. Okay, what is the E activation for the forward direction? I hope everybody now know the meaning of forward. Forward means reactant to product. How much is the value? Value. Activation energy, it is 900. So these energy profiles can be there. And they may ask you to calculate all these things. plus 400. Activation energy is always endothermic. See, you are going up. Energy is used up. Minimum energy needed 400. What is the activation energy for the reverse direction? Reverse. Reverse means product to reactant. It means this one. It is 900 minus 200. That is, Sanjana, why is it minus? Yeah, plus 700 kilojoules. Which reaction is faster? Reactant to product or product to reactant? Okay, good. This is faster. The reason? Low activation energy. But who is stable, the reactant or the product? So can I say rate of reaction is also very selective. Rate is faster with low activation energy, right? And stable substance, in the direction of stable substance. So it's always, that's what nature wants. So rate is also supporting nature. Rate will be faster for a stable product, right? So children, energy profile of exothermic, endothermic clear? The meaning of negative and positive. Okay. I'm writing an equation. A is reacting with B, giving you C plus 200 kilojoules of energy. Okay, so this reaction is exothermic, endothermic. See, Shriyan, generally I'm saying, okay, is it okay now? When I say, can I erase it? If you have to write, then you can stop me there, okay? Okay, moving on, children. Back to the same question. A is reacting with B. If you see, I'm teaching you with the help of questions so that you can understand how to apply the concept also. Concept in thermochemistry, sign convention, delta H, all these are done. Now very simple things are there. So you will see most of the time we'll be doing questions. A is reacting with B to give C plus 200 kilojoules of heat. This is exothermic, endothermic. This reaction is exothermic or endothermic? It is exothermic. Why? Yes, Sarayu, can you give me the reason why? Because it's releasing this much amount of heat. So in exothermic reaction, heat is the product. Remember that. Heat is the product. If somebody asks you to make the energy profile, so exothermic A is here, A and B are here, and C is here, like this. This is exothermic. See, energy needed to break the bonds is less. Energy released when new bonds are formed is more. You can see the difference. This is negative, exo. This is positive, endo. This is bond breaking. Are you aware of this? Did I explain you these things? So write on this diagram also. This one. What is here? Energy. Here, progress of reaction. So when you are starting with the reactant, what is here? Reactant. What are doing with the reactants? We are breaking bonds. Breaking bond. This is breaking bond. I'm making it here. This one, this blue is breaking bonds. Bond is attractive forces. We are breaking attractive forces. Energy needed. Breaking bonds of the reactant. Energy needed. Endothermic. Attraction breaking, energy needed. And what is the other side? After crossing the activation energy barrier, what is here? This one. Energy released. Why? Because bonds are forming. Now bond formation is taking place. Bond formation for the products. Bond formation. In products, bond formation means attraction making. Attraction making means energy releases, right? This is exothermic. Now, the difference of this energy needed, energy released, will tell you whether the reaction is exothermic or endothermic. Like in this case, the difference is 200. Means this difference. Which difference, children? Reactant and product. This one. This is the difference. This one. And is called as delta H reaction, which is HP minus HR, which is here minus 200 kilojoules. Means energy released is more, required is less. Are we clear about this diagram? So please write on this. Done? Now back to the question here, the green one, the one which I was doing earlier. Can I erase this energy profile now? Shriyan? Okay. Now back to the question here. When A and B are reacting to give C, what is the system here? Identify system. System is the reaction. This reaction A plus B and C. These are system. Where this energy is going? To the surroundings. And what is surroundings? Everything around it. Everything around this system is surroundings. So surrounding is gaining heat, right? Gaining heat. As I told you earlier also, surroundings is for the physicist. Physics people, they work on surroundings. Chemist, they work on system. So surrounding is gaining heat. It's gaining plus 200 kilojoules. Reaction is losing minus 200 kilojoules. So amount of energy lost, heat lost. In our particular example, heat lost is by system. In this example, in exothermic, is equal to heat gained by surroundings. But whenever we are saying heat lost, it should have a negative sign. You have to take care of sign convention. I'm writing it again. Heat represented by Q lost minus is Q gained plus. Can you see the magnitude is same? You cannot create or destroy energy. If one system is losing 200, exactly same amount is gained by the surroundings. Mathematically, if you look at this equation, rearrange. Can I rearrange it like this? Q gained plus Q lost must be equal to 0. First law of thermodynamics, that the energy of the universe is conserved. Delta U, you remember I said energy of the universe is never changing. Change in the energy of the universe is 0. Because whatever amount of heat lost by the system during a change or gained by the system, exactly same amount of heat will go in the surroundings or given by the surroundings. That's what you are going to follow. This equation is important, children. Are we clear about the meaning of exothermic and how to represent that exothermic reaction in the form of an equation? In exothermic reactions, heat is product. Okay, Sarayu, I'm writing the next equation. You're going to help me? Check. C plus D plus heat giving you A. What is this reaction, Sarayu? Endo exo. Very good. From where are you gaining this heat? From where this heat is coming, children? Surroundings. So when, okay, this is the system, and you're saying this is the system, this one inside, outside surroundings, and you're saying heat is flowing from the surroundings to the system. That's what you're saying, right? Heat is flowing from the surroundings to the system Q, right? What is happening to the temperature of the surroundings when this reaction is taking place? What is happening to the temperature of the surroundings? Yes, yes. Like for example, if I say H2O solid to H2O liquid, what is it? Is heat gained or heat lost? Is it endothermic or exothermic? This change. This is the system. Heat gained or heat lost? Why? Sarnia is right, but why? In solid, particles are tightly packed. They have, now we are going into unit 3. In solids, particles are tightly packed, right? And here, particles are liquid. They are not so tightly packed. So, solids have more stronger attractive forces. IMF is more. Agreed? Liquids, IMF is less. More to less energy needed. You're breaking IMFs, you're breaking them. IMFs are attractive forces. You're breaking attractive forces. Energy needed, right? You remember this is called as delta H of fusion. This is fusion. This also we discussed and we are going to do more about it in this unit also. So solid to liquid is fusion, right? Endothermic, heat is on this side. So from where this heat is coming? This heat, from where it's coming? Surroundings. So what is happening to the temperature of the surroundings? Can I say this process is around us as snow melting? When snow is melting, that snow is taking heat from the surroundings. Snow melting is a very depressing kind of thing. People are not happy during that change. It's wet everywhere and it's very cold also because that snow has taken heat from the surroundings for melting. So every time when the temperature tries to go up, snow is melting because temperature is rising. But as temperature rises, snow is gaining heat, taking heat from the surroundings, melting. Temperature goes down. Then temperature again rises, then again goes down. So people they fall sick during that time also because there is so much variation in the temperature, right? So snow melting is endothermic. During snow melting, the surroundings they become more colder. And what about this? H2O liquid to H2O solid. Liquid to solid. You are going in the reverse direction, children, now. Attractive forces are increasing. You are increasing the IMFs. You are increasing the attraction. Is exothermic, yes. And where this heat is going? Where this heat is going? To the surroundings. What will happen during snowfall? People are happy, enjoying. Initially, when snow is falling, weather becomes, surroundings, they become warm, right? Okay, so snow melting, snowfall, they are endothermic, exothermic process. And they are taking heat. You're not, when the snow is melting, you're not heating that snow. You're not going outside and placing heaters to melt it. You cannot do that. Who is doing that? Surroundings. And in the surroundings, heat is coming from the sun. Sun is giving us heat. Okay, so these are clear. We have already done it. Now then there is thermochemical equations and their meanings. What is thermochemical equation? First thing that you have to understand when you are using a thermochemical equation, you have to show the state solid, liquid, gas of the reactants and products in the parenthesis like this. You will be calculating delta H of the reaction. Delta H of the reaction will have units of kilojoules per mole. This is for 1 mole. If you change your moles to 2, 3, 4, then definitely the amount of energy needed or released has to be multiplied by that factor. See here. If I give you a balanced equation like this is melting, snow melting, right? Ice melting. It's endothermic. See the sign of delta H. This value represents for 1 mole. But if I make it as 2 moles, then what happens? Then I have to multiply it by 2. If I make it 3 moles, then I have to multiply by 3. If I say there is 180 grams of ice at 0 degrees Celsius, I want to convert that into 180 grams of water at 0 degrees Celsius without any rise in temperature. It's melting. It's a phase change. Temperature is not changing. How much heat is needed? So it's just fusion, right? Nothing else is happening. So how much heat? Now Q is for 1 mole is this. But how much is for 180 gram? So you convert your 180 grams of water, of ice, into moles. 1 mole divided by 18 grams. And then you multiply it by this value, this ratio, 6.01 kilojoules per mole. How much will be the answer? This one? Answer will have two significant figures because this number has two. So you can write like this. We're understanding this first rule that delta H reactions, they represent a fixed quantity, 1 mole. Depending upon how the unit is given to you, they keep changing the units. In place of kilojoules per mole, I've seen some students, they are dealing with this unit also, kilojoules per gram or joules per gram. So you have to be careful what unit they have given. Generally, we are using this. This is standard format. But yes, they can give you like this also. Are we clear? So that's the first rule, that you have to take care of the coefficients. If I reverse this equation, reverse. Reverse means this is fusion. Fusion means melting, solid to liquid, fusion. But if I do it like this, what is this process called as children? This one? Freezing. This is freezing, right? And this is called as delta H of freezing. What's the value of delta H of freezing? Exactly same as fusion. But this is needed and this is released. So if you reverse the reaction, your delta H sign will get reversed. Are we clear? This one is plus, this one is minus. So when we reverse the equation, delta H sign will get reversed because exothermic will become endothermic, endothermic will become exothermic. Magnitude is not changing. This I already explained you. If I multiply the above equation by 2, I have to multiply delta H also by 2. These are very important for Hess's law. The physical states are very important. Check this, children. These two values are different. Why? Because one is solid to liquid. Other is liquid to gas. One is fusion, delta H of fusion, melting. Other is vaporization. And in unit 3, I discussed with you and we did the reason also that delta H of vaporization for all substances, not for water, for all of them, is always much, much greater than delta H of fusion. Why? Any one of you? This is a question. Mhm. Yes. No reason? Okay, you know that solids have very strong IMF? Yes. Yes. Shriyan is trying to give me the answer and he is very close, very close. Liquids have weaker attractions, weaker, but they are still attracted. Cohesive forces are still there. They are still holding each other. It's slightly weaker. They are free to move, but they are not independent of each other. They are holding each other. Attraction is there. What about gases? Ideal gases, negligible attraction, very less attraction. So going from liquid to gas is more difficult because you need a large amount of energy to break all attractions because this is negligible attraction. It's a very important question. Negligible attraction means we have to go from attraction to negligible. But here, what are you doing? You are simply weakening the attraction. Attraction is still there, but slightly weaker than solid. You're understanding this, children? So, what Shriyan has said that more energy is needed. Why more energy is needed? Because we have to break all attractions. Whereas solid to liquid, you are not breaking all attractions, you are making them slightly weaker. That's it. Dhruv, what are you writing? Solid to liquid is less energy. See? Solid to liquid, less. Liquid to gas, more. Dhruv, check your statement again. Yes, Lasya, if attraction is less, then molecules are free to move in any direction. And in gases, attractions are minimum. Unit 3, gases, solids, liquids, right? Okay, let's do this question. This one. Ready, children? Sarayu, Saranya, those who are not participating here. Siri, you're there? You have understood everything? Siri, are you there? Yeah. So that's a very important question. I will be asking this question again and again. We are going to do heating, cooling curves, this fusion, vaporization, they will come there also. Read this question and how to do it. Let's do the planning. This amount of heat, is it released or required? See the minus sign. Most of the combustion reaction, this is combustion. Most of the combustion reactions are exothermic, all of them. This you have to keep it in mind. All combustion reactions are exothermic. Combustion means one of the reactant is O2 and you are getting oxides. That's combustion, burning in the presence of oxygen. P4 is burning in air. In air, we have N2, we have O2, we have CO2. But which gas is reacting? Only O2, right? So air means O2 for combustion. N2 will not react, CO2 will not react. Okay, how to do this question now? This is for, look at the balanced equation, it is balanced. This is for 1 mole of P4. So they have given me 266 grams of P4. I convert this into moles of P4 like this. This is the molar mass. And I will get the moles. See, grams P4 cancelled. From moles of P4, where will I go? to delta H. I'll plug in this ratio. I hope you can see my mouse. This ratio, I'm going to plug in this ratio. This in the numerator, this in the denominator. And that will give me the heat. Delta H is the heat. See? And answer is, but is this the heat needed or heat released? It's released. No, it's released. It's not plus. Okay? How much heat is evolved? So you can you can answer it in two manner. You can say 6470 kilojoules of heat evolved. Then we are not placing negative because we are writing evolved, released or evolved. We are writing means negative. Or you can say delta H is minus 6470 kilojoule. Don't use per mole now because it is for this much grams. So this. So whenever we are writing delta H, put minus plus. But when we are using the word heat evolved, heat added, then we can avoid placing the sign because this is clearly telling us, right? Are we clear for this question? Can I erase it? Sarayu, this dimensional is clear. So right now I'm using dimensional for even this part. I think now we are left with questions only for the remaining class. All of you, please be attentive now. Your turn. Questions. I won't answer from all of you. Please answer here. Read the question. Okay. Answer my questions first. The reaction is endothermic or exothermic? Endothermic. Endothermic means heat is on this side, right? So can you answer this part now? Why high temperatures are needed? Because reaction needs heat. It's an endothermic process. We need to supply heat. If you raise the temperature means you're supplying heat. Yes, you can say that also high activation energy. Yes, Dhruv. But now next question. Because Dhruv and Lasya started talking about high activation energy. And now I'm giving you one statement and then we'll try to figure out why. You know, generally in all N2 reactions, heat is needed. High temperature, whether it is endothermic or exothermic, doesn't matter. High temperature is needed in all of them. It can be exothermic, but still high temperature is needed. What is the reason? Any one of you? Any one of you remember Louis Stott's structure of N2? N2 is so abundant, nearly 78% of N2 in air, so abundant in air. Why? Because it is unreactive. Why it is unreactive? Because it is very stable. Why it is very stable? Because of a strong triple bond. This is N2. Yes, multiple bonds. Very good, Dhruv. So as AP student, be familiar with N2. Why is it so abundant in air? Because it's not reacting. If it is reacting, it will not be so abundant. O2 is reactive. O2 is not so abundant. The material which is very abundant is more stable. In biology also, the species like humans now are very stable. So they are more abundant. Humans are more abundant as compared to other animals. Reason? Because we are very good in protecting ourselves. We are stable. Same here. N2 is not reacting, so it is abundant. Why it is not reactive? Because of the triple bond. Very strong attraction. Three bonds. Three bonds means more attraction. It is triply bonded, very stable. We are good? Answer this question. Yes. N2 is very less reactive. Shrihan is still talking about this question. So we can say, we can end the question by saying reaction is endothermic. So heat is needed. So high temperature is needed. And you can add this also. An N2 molecule is very stable with triple bond. So a large amount of energy is needed. Activation energy is high to break the bonds. And that is the other reason that temperature is needed. Okay? Two reasons. One, endothermic. Second, one of the reactant is N2. Okay, question 42. Read the question, please. Is this reaction endothermic, exothermic? Yes, Shriya. Is this reaction endothermic, exothermic? Shriyan is asking delta H reaction is HP minus HR. Is he right? Yes, he's right. Okay, so keep asking these simple questions because this is how you can memorize. The way Shriyan is asking, typing, all of you can answer him. Yes, you're right. Delta H reaction is HP minus HR. Is this reaction endo-exo? This reaction, endo-exo. No, 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 no. Shirian, you didn't read the question carefully. Dhruv is right. What about you? Sanjana, good. Sarayu, Sri, okay, good. Who else is not answering? Saranya is answering, okay. Okay, okay, good. See, I have to come back and check the list of the students here. Yeah, good. Keep answering simple questions. EXO, why? Because this is minus 227 kilojoules. Negative sign. So where should I write heat? On the product side. Where the heat is going? To the surroundings. What is happening to the temperature of the surroundings? Temperature of the surroundings. What are the surroundings? That factory, the plant, the container in which you are manufacturing it. You're manufacturing this sulfuric acid in a container, big container. It's a big factory. The economy of a country is judged whether the country is a progress countries or developed or developing. These, they identify like this. One of the factor is how much sulfuric acid that country is manufacturing. It is one of the most important compound in synthesis and making materials in factories. When one of the most important, everywhere it is needed. It is also called as king of the acids. H2SO4 is unit 8, children. King of the acids. It is one of the strongest. It is one of the most required chemical in synthesis, in manufacturing clothing materials, plastics, whatever materials are there around you. In all these manufacturing, this is needed. So where the heat is going? To the surroundings. And what is happening to the temperature of the surroundings, Sarayu, Saranya? What is happening to the temperature of the surroundings? When the heat is coming to the surroundings, temperature will go up. If this is the container in which you are manufacturing sulfuric acid, what happens to the temperature of this container? Will go up and container can explode. High pressure, container can explode. So what should you do? That's the question. You should do cooling of the surroundings or you should do heating of the surroundings. You should provide heating or cooling. Yeah. If you see online picture of contact process, this is the process we are using for the manufacturing of sulfuric acid. Then in that you will see there is a container like this and they have a shower here. They shower the container with water, this water, so that the heat released is taken by water, right? Water gives the cooling effect. We are good with this? So simple questions. So we are going to do cooling. Why? Because reaction is exothermic. Heat is coming out to the surroundings. Temperature of the surroundings of the container in which you are manufacturing it is increasing. If you don't cool it, it will explode. Answer this question. Okay, I'm representing them and I'm going to call them, I'm going to give the name also. This is KBr solid. You are adding water and it's becoming KBr aqueous. This process is called as dissolution. Okay, Shian, I'm not interested in answers. I'm interested in discussion because we are not just looking for answer. We are looking up for understanding also. So what is it? Delta H dissolution. So delta H's are defined with the name of the process also. Delta H combustion for a combustion reaction. Delta H neutralization. You will see so many delta H's. Delta H combustion is for combustion reaction. Delta H neutralization for acid base reaction. Delta H vaporization, liquid to gas. Delta H fusion, solid to liquid. Delta H sublimation. Delta H latex. Latex we have done in unit 3. Delta H hydration. That also we have done in unit 3 when we were learning about Coulomb's law, attractive forces. So these things we already know from unit 3. See, so many ways. So this is dissolution. Okay, before you answer this question, can you tell me what is the system here and what is the surroundings? System is KBr. KBr is the system. And what is the surroundings? Water. You are adding plenty of water. Immediate surrounding is water. And what is happening to the temperature of the water? What is happening to the temperature of the water? Solution, see, it's getting colder. So if it is getting colder, the heat is taken or heat is given to water. No. If heat is given to water, then temperature should go up, Dhruv. Water is becoming colder. Heat is taken from water. Yes, Shrihan, Sanjana, good. If heat is taken from water, then this process is endothermic, exothermic. It is endothermic. The system is taking heat from water. Heat is flowing. This is a very popular question for AP exam. Always remember, if they are talking about a solution temperature, in the solution we have generally water, and water is the surroundings, not the system, because water is not doing any reaction here. It is just giving the surroundings to the system. Always remember that. Water is the surroundings here, right? So this dissolution process is endothermic. So A is endo. Now, based on this understanding, let's try to understand two others. B. What is B? What type of reaction? Through what I'm saying, solution is not the system. System is this KBr to KBr aqueous. This is system. Solution is water. In the solution, what is more, KBr or water? Water is more. The solvent. Water is the solvent. That is the surroundings. System is KBr, right? Shirian, you have to wait. You have to think before you answer. Follow me, okay? Your answer is wrong. Okay, children, follow me. Dhruv, you're okay with first question A part? Dhruv, KBr is the system. KBr is dissolved in the water. Water is the surroundings. Solution has the main component water. Water is in excess. So solution can be taken as surroundings. But in the solution, what is the surroundings? Water, not KBr. Okay? Hmm. Right. We are on the B part. Look at the B part. Identify what type of reaction is this? Combustion. And you remember I told you most of the combustion reactions, most of combustion reaction, most, we can say all of them, all combustion reaction, not most, use all, are exothermic. This is fuel. We are using it for warming your house. In USA, you're using this methane gas. You know, during winters, the houses, they stay warm. Why? Because we are burning methane gas. Heat is supplied by the combustion of methane. So this is combustion reaction. This is exothermic. Shrihan, you have understood your error? First, you identify what is a furnace. Furnace is something where the temperature is very high. You must have seen people are using small furnaces, very small furnaces in the houses also when they are doing a party. Uh, they use it outside the house. What you call it as for cooking food inside it. It has a very special name. I'm not remembering now. So furnaces, in the furnaces, we are doing exothermic reactions. You are maintaining the temperature of the furnace by combustion of coal, methane gas, petrol, diesel, all these on combustion, they give you energy. C part. Ready for C, children? Sarayu, answer it. This is based on this understanding. The process is called as dilution. We are adding water in a concentrated solution. Unit 3 again, children. Is this dilution exothermic or endothermic? H2SO4, concentrated, water added, H2SO4, diluted. Is it endo exo? So what is happening to the temperature of the solution of the water? Yeah, what is happening? Dhruv, Sarayu, what is happening to the temperature of the solution? Yes, Siri, you are right. Very good. Excellent. Sarayu, good. So if the temperature of the water is increasing, it means during dilution, heat is released. And then this heat is gained by the solution, right? And the temperature of the solution rises. So it is exothermic. Shriyan, you're good with this now? Okay, now let's see D part. This is a heating plate. Heating plate. And this is a kettle. Okay, I'm not very good in drawing. In the kettle, there is water, right? The kettle, the heating plate, all these are surroundings. Water is a system here in this case, only water. And you are boiling water. So from where the heat is coming? You know, heating plate, you are using some gas or something. So heat is supplied in the form of electricity or in the form of combustion of a gas, right? Heat is supplied to the plate. Plate is giving heat to the kettle. Kettle is giving heat to the water. So system is gaining heat and is getting converted into gas after boiling. What is it, children? Endo exo? Endo exo. Fast answer, please. I've already explained you. You can see how the heat is flowing. I've already told you this is system, this is surrounding. Is water gaining or losing? Yes, Sri. Again, Sri. Very good. Water is gaining heat. So these are the questions which can be there. So you have to think very clearly. You have to see what is the system, what is the surroundings, how the heat is flowing, and then you're going to say is endo exo. Okay? Endo means heat is going in the system. Exo means heat is going out of the system. Again, one another important question on the same concept. Ready? I'll go slow with this. I'll wait for the answer. All combustion reactions are yes. In the car engine, you are doing combustion of gasoline, which is giving you energy, and then you are converting that energy into work. You know, car is moving. So, you know how this is working? During combustion, the internal energy is increasing. That internal energy is applying a force, pressure. It's in the form of gas. Gases have very high kinetic energy. So they are applying force, pressure on the piston. There is a piston there. And that piston is connected to the your tire tubes of the car. So piston is applying force on the this tire tube, forcing it to move. When you apply force, it will move. And that's how your car is running. So piston is continuously forcing the tire tube, the tire of the car to move. And this piston is getting force from the energy. Energy we are getting from this chemical reaction. See how scientists have converted combustion energy into motion. This is motion. This is work done. You are doing work. Your car is doing work from this combustion reaction. Right? Okay, so this is exothermic. A is exo. What about B? Tell me the change in state. Condensing. What is the change in state? Solid to liquid, liquid to gas, or gas to liquid, or liquid to solid. What is the state change? Condensation. Condensation. What is it? H2O gas. Dhruv, very good. H2O gas to H2O liquid. What is happening to IMF? IMFs. Increasing or decreasing? IMFs are increasing. Attractions are increasing. So what are you expecting? Exo, endo? What are you expecting when attractive forces are increasing? Energy releases or energy needed? That mantra in chemistry, unit 2, when we were doing periodic trends? It's exo. Yes, it is exothermic. Attractive forces are increasing, then it means energy releases. Only Dhruv and Shrihan? Okay, now let's come back over here. Now this we have understood. Now let's come back on B. What is the system here? What is the system? Water. And what is cold pipe? Water as a gas is the system. Cold pipe is the surroundings. So when water touches the cold pipe, temperature of the pipe is very low. So heat flows from water to the pipe. Heat flows, right? So the process is exothermic. This is condensation of water is exothermic. Is it clear, children, to all of you? Very important question you are doing right now. Multiple choice questions. C part. Solid to gas. Attractive forces are increasing or decreasing? IMFs. Unit 3. IMFs are increasing or decreasing? I won't answer from all of you. IMFs are increasing or decreasing? Is decreasing. Very good. Means you are breaking IMFs. You are breaking attractive forces. Endothermic or exothermic? Breaking attractive forces. Endothermic. Heat is needed to break the IMFs. Chemistry mantra. Here. Okay. I'll not speak anything now. I want answer. Final answer. Endo exo. And then we'll discuss the reason also. Think and put your answer as endo and exo for the D part. When you're writing the answer, you will write D in front so that I should not get confused with what written here. Put D and then answer. Think hard, okay? There is no hurry for the answer. Perfect, very good. Those who have answered. Dhruv, Siri, Lasya, Sanjana, Saranya and Sarayu are not answering again. Do you agree with them? Because their answer is right. Now, Sarayu and Saranya, can you give me the reason why this answer is right? Why this answer is right? What are you doing here? What are you doing? You are breaking a bond between F and F. You are breaking this bond. Bond breaking, endothermic. You remember activation energy and all these things. What is this process? Bond breaking. What is this process? Bond formation. Bond breaking is attraction breaking. Attraction breaking, endothermic. Yes, Siri. Very good. Perfect. So these are one set of questions, multiple choice questions, which can be there in the exam. So you have to identify what are you doing. You're breaking attractions, making attraction, breaking attraction, endo, making attraction, exo. Then you have to be very careful with system and surroundings. So whenever you're making solution, if they are using the word solution, then solution means water in plenty. So water is the surroundings. And whatever change, dissolution or reaction, whatever is happening. No, the reason is because F2 is a molecule with FF bond. Shirian, you have to understand clearly. There is FF bond. That FF bond is broken. This process is bond breaking. And bond breaking is attraction breaking. And attraction breaking needs energy. That's why it is endo. Bond breakings are always endo. Right? Moving on, children. Ready for this question? This is the question in which you are going to calculate the value of delta H of the reaction. So this is given exothermic, right? Can you answer A part? Excess O2 means it's not a question of limiting reactant. Because if this is an excess, then who is the limiting reactant? Fe. And they are asking 4 moles of Fe will give you how much heat? No calculation needed. You can answer it very fast. 4 moles of Fe will give you how much heat? Yeah, same amount. Yes, very good. This much. Now you can write the answer like this. 4 moles of Fe can give, you can use plus sign also, but you will say kilojoules of heat released. If you write it like this, again it is correct. If you write it like this, again it is correct. If you are not using minus, then you have to write this word, heat released. B part. Ready for the B part, children? Now this is for 1 mole of Fe2O3. 2 moles are giving you this much. 1 will give you how much? Hmm. Half of it. Yes, half of it. Very good. How much is that? I think somebody's answering. She's answering as minus 826 kilojoules. This one is minus 1652 kilojoules. Okay, now C part. Is this you answering for the Shirihan for the C or B? Which one you are answering? No, no, Shirihan, not at all. This is random answer. How can you say that? Because if you see here, what is given? 1.00 grams. It's not mole. You are taking it as a mole, right? So read the question carefully. He has taken this as mole. That's why he's answering like this. So what we have to do? We have to go from 1.00 grams 368 of Fe to moles of Fe to kilojoules. So I will use dimensional 1.00 grams of Fe times 1 mole of Fe divided by its molar mass. We'll see the periodic table. Molar mass is, I think, 55 point. How much? Anyone? You have your periodic tables next to you? 55 point. Then what's the molar mass of Fe, Shrihan? Mm-hmm. 55 point. Yeah, okay. I was thinking the same. Times, plug in this ratio. Minus 1652 kilojoules is given by 4 moles of Fe. Can you see how you can use even the delta H values in your dimensional? You can relate them with the moles like this, and you will get the answer. An answer should have 3 significant figures. So minus 1650 kilojoules. You all are okay with this answer? So, Shriyan, you have to slow down when you are answering. You have to read the question because here there is no competition. We are learning, okay? There is no test going on. So, you have to read the question carefully, what is given, then try to answer. Reading the question fast is also important, but reading the question correctly and fast. So first priority is read it correctly, and then we can practice read it fast, answer fast. So maybe I will be more concerned about your speed during revision classes. But right now I'm more interested that you read the question correctly. Okay? D part. So we are going to read it correctly. We have to take care of the units, grams, grams. But here they didn't say that oxygen is in excess. Can you see that? Both the grams are given. This is a question of limiting reactant, right? So we have to identify which one is the limiting reactant. If you remember how to do questions on limiting reactant, that you start with your 10.0 grams of Fe, convert that into moles of Fe, and convert that into kilojoules using this ratio. Then you do the same thing with oxygen, 2.00 grams of O2, convert that into moles of O2 and convert that into kilojoules. Check who is giving you less energy, less amount of energy released. Please do not do that algebra here, okay? The negative sign, if the number is less, then it means it's a less amount of energy released. Less amount of energy released means you have to pick up the value which is less negative value is less amount of energy released, right? Understand this. And that is the limiting reactant, and that is the answer also. Remember, I told you that limiting reactant is the king of calculations. All the calculations will be done by limiting reactant. It is the one who is going to get finished first. Because we are not left with much time, so we can do this question again, D part, in the next class. So I'll see you then in the next class. If you have any questions, you can stay back.